Neural Machine Translation for Multilingual Communication. I'm Laura Godfrey, manager of the Multilingual Community of Practice, and we'll be talking about neural machine translation with Beth Flaherty, Director of Government Solutions at Sistran. She will describe what neural machine translation is and show us some government cases. We will have an opportunity to ask questions, and I really hope that we will have a rich discussion. Neural machine translation may be a concept that is new for some of us. In fact, the first academic paper is now quite 5 years old. So you're in good company if you are really lost at this point. So neural machine translation uses a large artificial neural network to predict the likelihood of a sequence of words, typically modeling entire sentences. Neural machine translation uses deep network learning and algorithms to pull up patterns that human beings are not quite able to recognize at this point. So in short, the more you use it, the better the process of translation will get. However, I want to make clear that no software can replace humans. What I see in neural machine translation at this point is a tool to potentially speed up the translation process and in time perhaps be much more cost effective. But I like to make clear that software output will require editing and proofreading. As you know, GSA and TTS do not endorse any tools or products. During today's multilingual community or practice session, Sistran will present a tool as an example of neural machine learning. This is one of many tools on the market and is being used across government and industry. This is not an endorsement of their tools by TTS, GSA, or the US government, or any of its employees or contractors acting on its behalf. And with that, Beth, take it away.
Very good. Thank you, Laura, and thank you, the GSA, for allowing me to present. Hi, everyone. I appreciate that you're taking time out of your day to learn more about using neural machine translation for multilingual communication. By the end of this presentation, my intention is that you'll have a better understanding of 3 topics. 1, why neural machine translation and how it might be applicable to you. 2, what is neural machine translation and how is it different from the past technologies? And 3, what's next with neural machine translations? And what are some of the new innovations that we can expect to see? Since most of you in the audience work in the government community, this presentation will be targeted for you. And we have a lot to cover, so let's get started. So why neural machine translation? What's all the buzz? Well, it has been newsworthy. Typically, the language area doesn't get much attention or gets negative attention for mistakes. However, just in the past few years, like Laura had mentioned, machine translation has benefited from the advancements of artificial intelligence. Efforts from academia and the research communities have been pushed out and have built this newest generation of machine translation software. So as a result, you'll see headlines like these, and I'll give you a second to read through them. And of course, there's many others. And I wanted to reiterate what Laura had mentioned, and this is someone that's coming from the software field, that even though some of these headlines talk a lot about how machine translation is getting much better, it still will never replace the human. It should be considered as a technology to be used as a tool. And we'll talk more about this throughout the presentation, but please keep these 2 concepts in mind, that technology will not replace the human and that it should be used as a tool. And the other thing I wanted to clarify at the beginning of this presentation is that we'll be focusing on machine translation. And so that's the concept of transferring natural language processing text to text. So we won't be covering interpretation, which is speech to speech, or transcription, speech to text. And the other thing I wanted to address, just in case you catch me using acronyms, is that machine translation I'll also refer to as MT, and neural machine translation as NMT. So you might ask, well, how does language technology apply to me? Well, if you deal at all with multilingual content, I'd like to offer 3 reasons for what's in it for me. And yes, I'm very good at acronyms these days with a couple of middle schoolers. So the first one are government mandates, and I chose 2 that are applicable to this topic. The first one is the Executive Order 13166, which many of you should be familiar with, which provides for improving access of services for persons with limited English proficiency, or LEP. And as you might know, this EO has been around for almost 20 years now. And I've heard several agencies say that it's been a challenge to meet this requirement, even though it's been around for a while and they see the value in it. So this is another reason to consider technology and how it might be able to help you. The other one is Executive Order 13859. And this regards maintaining American leadership in artificial intelligence. So I propose that by using neural machine translation, you can address each of these executive orders. The second one is good stewards of taxpayer money. Like most technologies, if they're properly used, this technology can help you do more with less. And so you would be using the technology to speed up the work within the same amount of time. Also, since training an engine, machine translation engine, uses the work that a translator had previously done, it's the act of recycling work, so paying for it once and using it several times. I've often been asked, so how much money does it actually save? And of course, my safe answer is, well, it depends. I've heard everything from 12% to 70%, but there's a lot of factors that are involved. It could be language, it could be your use case, what type of machine translation engine you're using, if it's been specialized for your purpose. So a lot of these different factors. And the third, what's in it for me, is to combat the data explosion. I'm sure most of you have experienced a lot more content than, say, 5 years ago. So how do you deal with that? The number of translators you might have the same number of translators. And so they don't scale as well as technology as a tool might. So, and the other part is that translators, some of them need clearances, some of them you need for very specific languages or for domains. So that's another reason where inserting technology as a tool can be helpful. So to summarize the reasons, you can meet government policy expectations, save money, and also keep up with the increased volume of content, which hopefully makes your jobs more manageable. Another question I get asked is, well, how is machine translation being used in the government today? So traditionally, it's been used in the intelligence community for analytic purposes. Machine translation is used to triage massive amounts of data so that analysts can decide which documents are applicable to their missions. It's also used for communication, and here you see just a Skype screen, but you can input the machine translation into any type of chat system. So an example is working in the combatant commands with allied forces, where they need access to knowledge bases and a means to communicate amongst each other. So that's another use case. And more, it's being used as a linguist tool. And that is thanks a lot to the latest technology, neural machine translation. In the commercial sector, machine translation has been used for a really long time. And I know this because I worked for some of these larger companies. And it was a tool used behind the scenes as a way to speed up productivity and, of course, save money that could help with the margins of these companies. Not maybe the case for government, but still it can be used for the same purposes, to speed up productivity. I know that some translators do use online portals such as Google Translate right now as another resource. But I think that there's increased increased interest in looking at platforms that can be used on-premise behind a firewall for the purpose of data security, which is becoming more important, and also for the purpose of sharing assets amongst many people instead of just one use case. So our next topic is, what is neural machine translation? So I thought it'd be good to start with the evolution of machine translation. It's been around since the 50s and 60s, and my company actually got involved in 1968 building these rule-based systems. These systems are very labor intensive and relied on lexicographers to build dictionaries and then to work with linguists who could code the linguistic rules. The resulting technology was very fast and predictable, but it lacked pragmatic knowledge and fluency, so it had a very limited set of use cases. Fast forwarding to the early 2000s, phase-based and statistical machine translation was used. This technology, computational linguists would align sentences from previous translations that were done by professionals and build these bilingual corpora. They would then feed them into the statistical phase tables and go through the statistical data training. The result was much more fluent. However, it was a faster way to build a language engine. So whereas rule-based was very slow, very labor-intensive, phrase-based relied on information that was already there and just needed to be formatted. However, the sentence structure was still choppy and it lacked linguistic knowledge because it was just relying on segments of sentences. Moving forward, again, to 2016, efforts from the research community were being pushed into the mainstream. Neural machine translation, again, relied on computational linguists who would take the language data and process it through a deep neural net. This language data now is not only bilingual corpora, but can also be monolingual corpora and term bases or dictionaries. GPUs are needed because the algorithms are much more advanced. And as a result, you do have a neural machine translation. That's not to say, though, that even though the quality that I've talked about and the fluency is much better, that there aren't problems. The nature of artificial intelligence, as you may have read in the news, is that there are unexplained behaviors. So you may have heard of the black box and efforts that are going on to explore, what's going on in this black box. Well, the same is the case with neural machine translation. So these are the focus points of the researchers and the developers. And so we've seen some strange behavior like low frequency words, spewing out garbage, certain numerical patterns, and sometimes negation issues. So what we're doing at my company, for example, and throughout other researcher and developer groups, taking advantage of folks like computational linguists that look at certain languages, see where the patterns are, and then use data to retrain the engines to address these type of issues. So what has helped neural machine translation to evolve? Like mentioned before, machine translation benefited from the advancements in artificial intelligence and deep learning. And there are three main drivers. One is big data. So for the purpose of training the engine, there's a lot more data out there that can be mined and used for training these engines. The second are the maturity of the algorithms. Here, the coding is geared towards teaching the machine to learn itself versus telling it specifically what to do, as was the case in statistical machine translation. And lastly, the accelerated compute power. So as transistors become more advanced, the algorithms are able to work faster and more productively. And again, the number 3 that I keep using, but 3 main ingredients. So there are 3 main ingredients that go into building neural machine translation for a particular language. One are word embeddings to create a powerful language map. And this is a way of classifying words using numerical representation in a multidimensional space. So you see here in the slide, male and female and how they're associated with gender, and that would be reflected in the language map. Artificial neural networks, or ANN, which is the middle block here, provides the contextual knowledge. The first generation of ANN were these recurrent neural networks, and this slide is admittedly a year old and already it's out of date. What's used more and more now are self-attentional networks called the transformers. But the concept of the neural network is that it's composed of layers of artificial neurons, and they try to mimic how the human brain works. During the training process, the neural network is continually refined during what is called epochs or cycles by using reference data. So the idea is how you and I might learn a new language. So we start off slowly, we go back to the teacher, check our mistakes, go back, correct our mistakes, and we go through this continual cycle until we understand more and more. And when I mention contextual knowledge, it means taking into account the entire sentence in the translation. Older technologies would look at what's called n-grams, and as a result, the fluency wasn't there. But now with the sentence approach, the results are more consistent and the fluency is much better. The last one there is the attention models, and these are used to focus on the most important part of the sentence during the training model. The subsequent engine that is created using this process is then ready for use in language translation. So in this next slide, we're talking about the making of neural translation. So there's two phases, the encoding phase and the decoding phase. During the encoding phase, the input is analyzed and a complex sector of vectors is created. The vectors are the numerical representation that we talked about before in the earlier slides. During the decoding phase, a complete transfer process takes place where output is generated. Now, I'm admittedly not a developer or researcher, so I'm not the best resource for a deep dive into this subject matter, but if you had interest in learning more, I'd be happy to point you to resources that I'd recommend. So, what's most important about the result of neural machine translation that I keep mentioning is that the quality is much better. I've asked translators just for fun to look at some of the output from machine translation just to see what their reaction is. And those that haven't really looked at neural machine translation are typically pleasantly surprised. So it's fun with languages like Farsi and Vietnamese and Chinese, some of the harder ones that traditionally machine translation had a difficult time with. And I think this is the reason why more translators are having a renewed interest in how this tool might benefit them. But if you think about it, humans and machines can have a synergistic value whenever it comes to translation. Translators, for example, have the cognitive ability, which goes hand in hand with creative thinking, and many are skilled in a particular domain. With machine translation, you have speed, memory, and consistency, which is just a characteristic of technology in general. So if you pull this together in a sample workflow, just show one way which translators can work with machine translation. Here we have source documents that come in that need to be translated. And they can be translated by a translation server or whatever tool that you're using for the machine translation. Now, there are a number of different ways that these tools can be accessed. One is our translator tools, and there are several of these out in the market, and they're typically referred to as CAT tools or computer-aided translation tools. So machine translation can be considered just another type of translation memory or resource that can be used in this platform or user interface that a translator might use. Another one is our browser tools. So many machine translation vendors have web browsers that the end users can use. And unfortunately, we're not going to be able to do a demo today, but that is something that I'd be happy to show if there's an interest at a later date. The third is through API, and this is traditionally in the government space what is used. So there's a platform that might be used for analytic purposes or e-discovery tools where, again, there's not an interest in having two user interfaces. And so machine translation can be plugged in just as another tool on the toolkit for the end user to have access to. And the last way are user tools. And so user tools are a client application that can be put on an individual's desktop, for example, and a plugin essentially for Microsoft's Office. So for example, we can see a PowerPoint document and have a tab that gives you access to either translate a whole document or to translate and replace so that you don't have to move outside of that particular document. So that makes it very easy if someone just wanted to see the gist of what something says, or if a translator just wanted to do a quick draft and then work right in that document. There's many ways to do that. There's the idea of profile that you see in the yellow here. And for some tools, that is how you can layer dictionaries or translation memories, and translation memories being previously translated documents where you have both the source and the translated sentences side by side. Those can be reused in this idea of profile. And so a lot of times if you have something that you've already translated or maybe a veteran translator had, and you want to use that on top of a generic engine or a specialized engine, there's a lot of flexibility being able to do that on the fly and to do it yourself. So these user interfaces for these tools allow you to do that. And then here you see the people that will check and make corrections with the errors and put it into the desired style and then deliver the translated documents. But that's not the end of it. As I mentioned before, you can take what they had translated, bundle it into the source, and translated documents to create what's called and what I referred to earlier as by-text. Might create dictionaries or term bases out of that. They are fed through what is called in the industry a training server to build a specialized language model. And then that can be added to the catalog of machine translation that the end user can use again. So this is really good, especially in the government, if you have specific dialects within a language or domains, or just words that you prefer to be consistent throughout. This is a good way to be able to reuse that knowledge from professionals and to speed up the process later on. And one other point I wanted to make was that what happens in the translation server is very quick. In fact, it's typical that translators without tools can translate 2,500 words per day, and that was without tools. A translation server, on the other hand, can do that same amount within seconds or minutes. So again, bringing those two, the speed and then the ability of the translator together, can really work to your benefit to speed up the process, but still maintain the level of quality that you need. So these are just a few slides of the interface that where you can create your own resources. Granted, if you have dictionaries or if you have translation memories, you can import those into these machine translation tools, or you can create them right in the tool itself. It can be as little as 1 or 2 entries, or it can be thousands. So there's a lot of flexibility, again, that I wanted to mention with these tools. So the next topic is what's next with neural machine translation. As you saw when we talked earlier about the evolution of machine translation, neural machine translation is relatively a new technology. In fact, Laura made that point earlier too. The advancements have been very fast moving, and I wanted to point out a few areas that are being focused on as of right now. First one, user experience. As the use case broadens, end users find that they don't want to have to toggle between machine translation interface and their primary platform. And we addressed this before on a couple slides back. In response, machine translation providers are creating all these different type of connectors with translator tools or customer interaction platforms, analytic platforms. Another component of user experience, especially in the government, is that we need to be cognizant of requirements such as Section 508. So whenever someone is using our tool, we need to be able to have it as available as possible for accessibility purposes. So that I'm seeing more and more as, especially in civilian agencies that have an interest in looking at these technologies. Regarding quality, this of course is an ongoing focus. Researchers are looking at quite a few areas. One is how to process an entire document, or at least down to the paragraph level, instead of the sentence level where we are right now. And that would help with better consistency, better semantic knowledge of the document that is being translated. Another is how to train engines with less bytext so that we can create engines for less common languages. And that's really important in the government. It is becoming important in the commercial space, but I see it a lot in the government where there might be rare African languages or Asian languages that have been really difficult in the past for machine translation. But now with neural, the quality is better, but you still need the data. So they're looking at how can we have a smaller set of data to still be able to provide these types of languages. And third is how to build more domain and language combinations so that they are accessible down to a very small degree. So if you have something really specific about clinical trials in a less common language, how do you do that? And so one of the ways that we're doing it at my company is building a type of marketplace so that those with data can build their own engines using our tools and making those accessible to others. And it's also a concept that's being introduced into the government. So there are processes plus, of course, the technical attention to this idea of quality. And the last one is productivity. We continue to focus on speed. I can tell you when the first iteration of neural machine translation came out, it was very slow. It was slower than the old technologies. But just in the past year and the changes in the platforms that are being put out, we've seen a huge jump in this area. Another area, of course, in the government space is on cybersecurity. So as we're changing the architecture of these tools, we need to keep an eye on cybersecurity, given the focus on data. Any software companies that, like mine, that deal with government agencies that have classified data and PII we need to make sure that our software can continue to keep up with software accreditation so that they can be put on these specialized networks. And overcoming organizational challenges. In order for neural machine translation or any new technology for that matter to be used, it has to be accepted by its stakeholders. And if you were to ask me what is one of the biggest hurdles I face when I introduce machine translation to government clients outside of our traditional users, it's this one. But I found a couple of ways to slowly introduce it. One is this type of forum. Another is to give end users a risk-free way to try out. So there are ways that you can ask for user sites to play around with the technology. And of course, there are online free sites such as mine and some of the other big ones that are out there. The other way is to get all the stakeholders in the room and just go through thoughtfully how you might work this type of technology into workflow. And it's important to engage everyone so that they have a say. For example, translators, how can they help to make the system even better? Can they focus on helping to build translations and to make sure these translation memories are as clean as possible so that it possibly impacts any new machine translation engines that are being made? And of course, the last consideration and a very important one is return on investment. So weighing the benefits of the technology when it comes to the productivity and the cost. So that's the end of my comments. If you decide that you'd like to further investigate machine translation for your engine, I'd be happy to serve as a resource for you. I spent a good part of my career in this space, both in language services and now more recently in language technology. So I do know folks that I might be able to point you to within the government, and I found that to be very helpful so that they can explain their unique use cases government to government. Likewise, I can point you to specific resources just through some of the organizations that I'm involved in, or even chat with you based off of my own experiences. So please reach out if you think I can help and you see my contact information there. And that's the end of my comments. Thank you very much. I appreciate your time.
Thank you, Beth. That was a terrific presentation. I'm sure I learned a lot, and I'm sure that some other ones too. And now, if you guys have any questions out there, please, direct them to the chat. But I wanted to say to everybody that because of some difficulties today, we couldn't do the demo. So that is why the presentation is a little bit shorter. It would have been great to be able to do that. But if you're curious, just contact Beth and just get a demo for your organization or whatever. So I guess we'll wait a couple of minutes to see if there are some questions out there. I will make a comment. Like I said before, I learned a great deal, with this. And one of the things that excites me is that with new technology and with this way of learning and being able to input more stuff on the machines and train the machines to be smarter, right? So increase quality of the translations that we get, but perhaps an opportunity for the government to be able to serve even many more languages than today. Typically a lot of the government websites are offered in English and sometimes in Spanish, and because obviously the massive demand. But there are some other demands that perhaps we can meet at this time. And I'm hoping that technology will help us bridge that gap and be able to, be more, out there, with information, government information to actually serve more constituencies. So that's all I have. And if there are no questions at this point,
yeah. Thank you both. Yeah, just to sum up, thanks for joining today's webinar. You'll be able to find a recording link on the event page, which we linked to in the chat. And I've also put in Beth's contact information there in case you'd like to reach out directly to her. We actually do have one question that just came in from Kirby. Why is the term neural used? Neurons are only in humans, no?
Well, that's a good comment, and I think it is the attempt to mimic the human brain. So, of course, the ultimate goal is to make the technology as human-like as possible, and so it's just an attempt to reach that peak.
Well, and the fact that it's learning.
Yes.
And I think that that's where that term perhaps comes in. You know, that it's not a static software. You know, that software is, you know, regardless of what company provides that, the technology is such that it's learning as it goes along and it evolves.
Right, and in the technology, the algorithms are based off of what is called neurons. So very good question, thank you.
Yeah.
And we'll leave it open in case anybody else has last minute questions. Yeah. Looks like no one is typing right now. So again, thanks for joining today. And we'll see you next time.